Welcome back. This is John P. Kelleher for Fire 103 from Los Monos College, and Fire 103 being Fire Protection Systems and Equipment. This is now part six, and the final part of our lecture, part six. Okay, we're going to go over fire detection and signaling systems. All right, it's a long system. It gets pretty slow. Bear with me. Again, I need you guys to use this as a supplement if you can with your PowerPoint. It gives much better graphics, more information and such, but here I'm just going over the lecture and use your PowerPoint as a supplement either or. All right, here we go. The modern fire detection and signaling systems are a reliable method of reducing the risk of large loss incident. I also want to say that all this homework you've been doing covers a lot of the fire alarm systems and detection systems that you've gone over, so this shouldn't be new to you. Components of any system should be listed and tested by the UL and FM. We know what that is, Underwriters Laboratory and Factory Mutual. Okay, know what those two are. The installation of any system abides by NFPA 70 or 72, NFPA 72, know that. The system control unit is the brain of the detection system. The system control unit is the brain of this detection system, know that. It processes the alarm from actuating devices. It transmits a signal to local other signaling systems. The system control unit is thought of as the annunciator panel. Okay, the primary power of the system is the main connection of to the power company, i.e. PG&E, and the alternate or backup power is produced by a generator. You need some other kind of backup power. If anything kind of shuts down, an earthquake or if the power shuts down, that thing's got to be running. So it needs a backup generator or battery system, whatever, just so make sure it runs. That secondary power must be activated within 30 seconds of the primary power loss, and usually consists of a storage battery, engine-driven generator, or multiple engine-driven generators, okay? And actually, when I was in prevention back in the day, when I was being as a fire prevention officer we'd actually do a test. Remember, I think you guys mentioned this, we do an later in this lecture, pardon me, when we do a first test to make sure the system works and such that whatever location it may be, the alarm system, and we're gonna actually shut the power off, okay? And we're gonna have a clock, and we wanna make sure that the power kicks back on within 30 seconds. If it doesn't, it fails the test, okay? So it's gotta be activated within 30 seconds once that power is cut off. Know that. Okay, the trouble signal power is needed always. When we talk about trouble system, that means things you're gonna see on a panel, okay? And the panel could be at the main, as you walk in the main opening foyer of the building, you're gonna see like a readout, okay? And on the panel, we'll say first floor, second floor, third floor, whatever it may be. And then it will say, there'll be maybe a red light flashing or something like that. And it will say trouble, okay, flashing trouble. That means when it's in trouble, that means there's something going on. I mean, there's some kind of power issue or some kind of connections, but that's not bad. It's not working well, whatever it be. So it's in trouble. There's some kind of problem going on with the system. However, even if it's in trouble, it still needs to be working. Okay, that means even if it's in a trouble status, that means the system will still work. Okay, but trouble will just be alerted that something else is going on with that system, and that's going to have to tell the building manager, the owner, and then get them to repair that, and then let us know about it. Okay. The secondary part we know about that's trouble signal. Initiating devices can be manual or automatic. You know, there's between manual, you actually manually pull it down, or automatic system turns on itself. Examples of either device of manual automatic are pull stations, heat detectors, smoke detectors, flame detectors, and the combination of detectors of each one. We'll go over that later. The alarm indicating device is once the alarm initiating device sends a signal to the brain or that system control unit and processed by the control unit may sound alarms, transmit the emergency to the central service station or central station or a fire department dispatch center, okay? We'll go over about central station very soon. The local alarm devices include bells, buzzers, horns, voice messages, strobe lights, and other lights, okay? There are other services. Alarm systems, audible eyes, may shut down the HVAC system. HVAC system being the heating, ventilation, and air conditioning system. That means when you go to a building and you see like little vents, okay, around the building, they'll pump out amount of air to make the building cooler or warmer, right? You want a constant temperature 68, 72 degrees, comfortable for us, right? Well, that air, if it gets too cold, what are they going to do? The heating automatically kicks on. Rate of rise, okay? The air will change, make it nice and comfortable for us. Well, if it gets too hot, then the AC will activate, air conditioning unit, and it will cool that air as it pumps in. That air being pushed out into that vent is about 5 to 10 psi, so very low pressure, okay? So much that you can actually, if you want to, shelter in place, as they say. You can take some paper like this, tape it against your vent, okay? Just to regular Scotch tape it against the vent, and that will seal it off because it's such a low pressure. So when they talk about shutting down the HVAC system on the alarm systems is, they'll have big old vents around the building, okay, in the rooms, okay, and they'll have big old vents that shuts down that system, so that HVAC system no longer pumps air into that room, wherever location may be, because that could be smoke. We don't want smoke. We go from one part of the building to another, so let's shut down the HVAC system. So keep that in mind. The closing the smoke and heat doors and dampers. That's another thing about dampers, so smoke doesn't enter the area. It pressurizes the stairwells for evacuation. Why do we want to pressurize the stairwell? Why is that important? Because how do people get out? We get out with the stairs, right? So when they mean pressurize is, they're going to pressurize, they're going to pump air into it. So pressurizing, getting all that product of combustion out, carbon monoxide, and gases and such from the fire. It's going to pressurize the system, so all that bad air is pumped out and the good air is backed in, so that's in the stairwell. So when people go downstairs and exit properly and get out of there. So we want that stairwell area and where you breathe is to be good, clean air, okay? Or as best they can. So they're going to pressurize the system, pressurize with air, okay? Pressurize it, pump all the bad air out so that air that's tolerable so people can go down and exit through the stairwells. That's what I mean by pressurizing the stairwells. Override elevators and have them open the doors on the fire floors and return to the first floor. So what happens is, if you're on the 36th floor and you want to get to the 50th, if the alarm sounds, you're not going to go to the 50th anymore. It's going to the doors will shut, and that elevator is going to go down to the first floor. Okay, you want to go to the 50th. That could be where the fire is, of course. Okay, so the doors will close automatically when the alarm sounds, and the elevator will immediately go down to the first floor. Operates heat and smoke vents, activate and actuate special extinguishing systems. We just went over in the part 5, didn't we? Okay. The types of signaling systems, know this, there's either simple or complex. Simple is activate locally or within the building itself. Locally meaning is, locally is if you have a 2-story building and you have 4 units, whatever it is. When they mean local, that means it only happens within that building, locally, into that one building. It doesn't deal with Los Monados College, where the room we're supposed to be at. It will only deal with that one building, the science building. Okay, that's the local alarm. Stays in with the science building. But when they talk about general, that means it's all of the buildings around the campus. Okay, so understand the difference between simple and complex, or local. Simple, activate locally or within the building itself. Complex is activate, sounds the alarm, control services, and notify outside agencies. Meaning it not only just notifies the local and all these one buildings, but also will transmit information to other locations, like a central station. Cover that later in a bit. Systems installed depends on the level of life safety. That means us, you and me, okay? The structural features of the building, the level of hazard by the building contents, and the local and state fire codes. And building codes, of course, okay? There's major types of alarm systems. Know them. There's local, selective coded system, auxiliary, remote station, proprietary, central station, and emergency voice alarm communications. I'll go over each one. The local system is designed to transmit both visible and audible alarm to immediate premises and to other places. There are 4 types of local systems. There's the non-coded, the zone non-coded, the master coded, and the zone coded. I'll go over each one. Again, this is just for the local system here. So number 1, local system, 4 types. The first type of the local system is the non-coded. It's the simplest. It's the alarm activates, it sends to the control unit, and all alarms activate simultaneously. It looks for what the device was activated, and it's practical for all small occupancies. So non-coded is the simplest. That's like if you have an apartment building of maybe 4 to 6 units, you're probably going to have a non-coded local alarm system. Okay, you don't need this specialized big type of system. Okay, it's just for that one building. Okay, the zone non-coded, it's one step above from the non-coded. The alarm activates, it sends it to the control unit, control the brain, and then it's zone coded to alert where it's activated, and then it's used for bigger occupancies. So that non-coded system, that local alarm system, let's talk about one building for 4 or 5, 6 units. The zone non-coded is more for like a building maybe of 20, 15 or 20. So it's getting a little bigger and broader. The master coded is used in occupancies that use alarm signals for either purposes, i.e. like schools. The bells will differentiate sounding and differentiate each type of alarm. So when you go to different types of building around the school, the bells binging will go ding, 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 one tone. Another building will dong, 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 meaning they have different types of tones, different types of singing, different types of tones and such. And then the last type of local system, the fourth type, is same as the zone non-coded. However, each zone has a special listening or sounding code that's been activated, and usually they are short rings, a pause, and then 3 more rings, okay? Okay, moving on. Now we got selective coded system. Now we went to local systems. Now we're going to selective coded system. Selective coded system, it transmits a coded signal to the alarm receiving station, and its coded device is internal to the system. There are 3 basic devices that provide coded signals. There's the electric wheel, the electric relay circuit, and the computer-aided dispatch. Computer-aided device, I should say. Okay. The third type of system is the auxiliary system. It's used in communities served by municipal fire alarm box systems. Occupancy is directly attached to the fire alarm box. These are kind of outdated. This is back in the day when they had apartment buildings where they had the manual pull boxes. All the firefighters are taking these, like in the 50s and 60s, they had these big boxes with these, break the glass and such. Those are those auxiliary system with the alarm boxes, okay? Then you have the remote. The fourth type is a remote station alarm. The remote station system is the same as the auxiliary system because it's connected directly to the dispatch center, but the remote system is usually connected by a leased telephone line. So it's a telephone line connection between the remote station and each location. Then you have to talk about the fifth type is proprietary system. It's used to protect large commercial or industrial buildings like a high-rise. Each system is wired into a common receiving point on the facility. Another point I want to make about proprietary is we had Target on one of our main big targets where I used to work. Well, for the alarm sounded, alarm was pretty complex. That is, it wasn't simple. It was complex. We used to go there for the alarm. Something was going on. Okay. Find out what's happening, maybe a small fire or something's going on in one building. Then we'd have to find out what the fire is, put it out or whatever, or find out if it's in trouble, whatever it may be. Then we'd have to say, okay, we'll go to the building manager, say, okay, well, here's a story, we'll put it out. They want to tell notify the owner. And the building manager walk up to and say, excuse me, what's your name, sir? I go, I'm Captain John Keller, blah, 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 Elcida Fire. He goes, well, sir, I need you to talk to my main dispatch, my proprietary system at our main office. And I go, okay. I would get on the phone and talk to, I thought I was talking to some managers at home or whoever it may be. I'm talking to some person from Minneapolis, Minnesota. And that's because Target has their own proprietary system within them. And they also have their security system. They would actually police their own buildings, police their own areas. So our cops would say the same thing. When they talk about proprietary, that means they're taking care of their own building or their own system, okay? That doesn't mean we're not going to go to the fire or anything like that, but they have the most main responsibility of going on. So I'd have to get their say before I'd say, okay, well, the system's back in order. Here we go. And they'd say, okay, John P. Keller, you're from Elcida Fire. Thank you very much. Can we now activate the system? I go, okay, now it's back in system. Yes, sir, ma'am, whatever it may be. Click, I'm done. Meaning I have to go through their proprietary system. Target would do their own thing. So that's what I mean by proprietary system. The central station system, and this is what goes on with all big major alarm systems, the central station system, which I'm sure you've read about in your homeworks, it's the same as the proprietary, except the receiving point is at an outside contracted service point called a central station, i.e. ADT, in our case in the East Bay Alarm, okay? And basically that is, the alarm will activate, notifies everything through the brain, and the brain will transmit, and then it will transmit to what they call the central station. The central station is the main 24/7, 365, all year round. And that dispatcher, the central station, or ADT or Bay Alarm in this case, over in Pacheco, California, right next to Concord, they are alerting everybody, and they're saying, oh, there's an alarm sounding. Oh, there's alarm sounding at such at a Target in, well, I would say Target. We'll say we'll say Safeway and El Cerrito. So all of a sudden it's notified the central station, then all of a sudden they said the alarm sounding for Safeway. Then they're going to say, oh, where's that at? Oh, that's the nearest dispatch. That's a Richmond dispatch, or in this case, West Contra Costa County. They're going to notify Richmond dispatch or whatever dispatch we're at, notify their dispatch. Then the Richmond dispatch would contact each fire station in that particular area, and then we would respond. Okay. So the central station is that brain, that central the brain will now transmit the central station. The central station is the main area of whatever alarm system, and then they'll transmit to a dispatch center, wherever may that be. Okay? And then the last one is emergency voice alarm communication. It's a supplementary system that's placed in a facility to other systems that provides communication within the occupancy between the 2 points, i.e. like an instant command to a firefighter or a room to main room. We found that in the Social Security building in Richmond, and I think it was on... So I remember in the 20th, 21st, whatever, they had a 9-story building. They'd have a separate radio system down on the lobby to each floor. So let's say you're doing a fire up on the 6th floor. You had a way to communicate to the main lobby with a radio from the 6th floor down to the main lobby. And that's that separate emergency voice alarm communication. Okay? Then you have manual alarm initiating device. Occupants manually initiate the fire alarm signal. And again, when I talk about manually, that means you manually pull it. Okay, it doesn't automatically turn on. You manually pull it down. There's what they call a manual pull box. It's red in color. I think you've seen these. These are probably the ones where you got in trouble when you were in high school, when you dared to pull the manual fire box, which I'm sure you did not do, right? Which is good. That's when you actually pull that little manual pull down. Or a movie theater. Next time you go to a movie theater, look for the little red box. Sometimes they'll have a plastic cover on it, a clear plastic. If you bump into it and takes the plastic off it, the alarm will sound. But if you put that cover back on within 10 seconds, the alarm will stop. But if you bump it up, take it off, that plastic cover, and then go to the box itself and then manually pull it, that'll activate the whole system itself as well. So that's that manual pull alarm, manual pull box. It's red in color with white lettering. It's used for fire signaling. It must be mounted on the wall between 3.5 to 5 feet in height, from 3.5 to 5 feet from the floor. It's plainly visible. It's not to exceed 200 feet away, each one of them, one per floor, that is. Place them near an exit because we want to activate the alarm, pull it, and then get out of there, right? Older types had glass to prevent fire alarms, but now it's a hazard, so the glass is removed. And I think I told you about the old manual pull alarms. They had a glass with like a little hammer. You bang the hammer, open up the glass, then you pull the alarm, pull a toggle switch down. Well, in this case, they don't have that because you cut your hand, okay, with that glass. So those have been eliminated, okay? What else we got here? Coded pull box indicate where the box is. Non-coded just sends a continuous signal location. So what that brain do on the more technology advanced was, wherever you pull that alarm panel, like I said, when you walk into that building, when you first go in, they will say 3rd floor manual pull alarm at the main panel and say, oh, on the 3rd floor, someone pulled an alarm. So we're going to go to the 3rd floor, right? See where the fire is, okay? So, and then obviously, and if you have a non-coded system, it's going to pull down, it's going to activate the whole alarm system. The 2 types of manual pull boxes are single action and double action. Single action is just you pull the box. The double action is you open up the window and then you pull the box down. So that's your single action versus double action. Okay. Automatic alarm initiating device is referred to as a detector. Automatic alarm initiating device is referred to as a detector. Know that. There are 4 types of auto alarm initiating devices. There's a fixed temperature heat detector. There's a fusible link frangible bulb detector. There's a continuous line detector. And there's the bimetallic detector. The fixed detector heat detector is the oldest, inexpensive, and least amount of false activations. Slowest to activate. Heat detectors are placed at the highest level of the ceiling. Works on 3 principles. The heat causes the expansion action of the material. The heat causes the melting action of the material. And then the heat causes the material to have thermoelectric properties that are detectable. Okay? Then you have your fusible link frangible bulb. We know about that through sprinkler heads, right? Fusible link works just like the water sprinklers, but the spring releases, touches an electric contact, and then activates the system. The frangible bulb has a liquid that expands under heat, breaks the bulb, and then connects the complete circuits to the alarm. Kind of know that from the frangible bulb sprinkler head, don't we? Okay, then you have the continuous line detector. Continuous line detector is what they call, also known as a spot detector. and that heat melts the insulation tubing. The two wires then touch, which activates the alarm. So you have the wrapped tubing. As that melts, the two wires will touch, and that'll activate the alarm. And then you have the bimetallic detector. It has a bowed metallic strip. It's bowed, okay? It's bowed like this in a round bowed kind of shape, okay? And the contacts melt, popping the strip, which then activates the alarm. Are bowed. It pops and then activates, boom, as they touch. That bowed metallic touches, and that's how it activates the alarm. Those are 4 types of your heat detector detecting systems, okay? Oh, pardon me. Those are 4 types of activations for the heat detectors. Then you have rate of rise detectors. Again, these types of detectors notice a sudden rise of temperatures, okay? So just like your thermostat in your house, and we talked about the HVAC system is, remember I talked about 68, 72 degrees? If it gets too hot, it's going to cool it off. When it gets too cold, it's going to warm it up, right? Well, that thermostat will activate to make sure it's 68 to 72 degrees, right? The rate of rise detectors will activate because it's going to sense a huge jump in temperature, okay? So they'll quickly detect the increase in heat. They send a signal when the rise in temperature exceeds 12 to 15 degrees per minute. Know this. They send a signal, or they activate, when the temperature exceeds 12 to 15 degrees Fahrenheit per minute. So know that. There are different types of rate of rise detectors, and they're all automatically set. The pneumatic rate of rise spot detector, this is the most common, has an air chamber and a vent with a flexible metal diaphragm. It senses the rise in temperature within the chamber. There's a rate compensated detector that monitors slower than manual change in temperatures, as an outer bimetallic detector sleeve that expands when heated. The expansion is sensed and then activates 5 degrees Fahrenheit per minute. And then you have your thermoelectric detector. These are 2 wires made of different metals twisted around each other. And when the heat caused an electric current, the large changes to temperature activate the alarm system. These are all pretty technical, but again, you just want to understand how they all activate and how they start. Okay. Now we're going into smoke detectors. Smoke detectors sense the presence of fire quicker than a heat detection activation. Okay? So when you have smoke detection, that means they detect smoke. Okay? But then you have heat detection, they're going to detect heat. Okay? Know the difference. They are preferred detector and are used mostly in residential homes. Smoke detectors are preferred detector because they're usually most in residential homes, because we want you to not breathe in the smoke. Okay? Feel the heat, whatever, but worried about the smoke. The smoke comes before the fire, right? So with the smoke, what's going to kill you? Not the heat, but the smoke. So if we sense some kind of smoke, we want that thing to activate for you to get out of there, because you're not going to be breathing that smoke in, right? Carbon monoxide contains your body oxygen 1,600 times more than regular oxygen. Not good, okay? So carbon monoxide, we call that the silent killer. All right, moving on, excuse me. Okay, there are preferred detectors and used mostly in residential homes. There are 2 types of smoke detectors. There's a photoelectric and ionization. Know the 2. Photoelectric smoke detector and the ionization smoke detector. First of all, the photoelectric smoke detector. It's also known as the visible products combustion smoke detector. Has 2 ways of detecting smoke: and beam application and refractory application. A beam of light is focused across the area. When the smoke blocks the beam of light, then there's no current, then it activates. Okay? The refractory photocell passes through a small chamber, which light doesn't strike. The photocell has no current. When the smoke enters, it strikes through that chamber, produces a current, which then activates the alarm. Photoelectric responds quicker to smoldering fires, faster than ionization. Okay? So just understand it. Photoelectric responds quicker to a smoldering fire, faster than ionization. Okay? Again, when people ask you, you could be at Home Depot, you're with your captain, or you're walking around, people are going to walk up and they say, "Excuse me, sir, pardon me, firefighter, so-and-so, what type of smoke detector I get?" Okay? You should know this, and we can study all this. First thing is, I tell everybody, just get a smoke detector, number 1. What's the least expensive? Usually the least expensive ones are ionization ones, okay? But in any case, put one in. You want 1 per floor. You want positions. I'll show some positions in just a sec. But what types are better than others? There are better others in different circumstances. But the reality is that smoke detector is much more important than having activating, pardon me, you want to detect smoke before you detect heat, okay? And then as far as smoldering operation, this photoelectric, it does activate quicker the smoldering fires, but the idea is that ionization can do other things as well, okay? But in any case, you want one of those things in their building, and you don't want it in their room. Where do you want it? You want it in the hallway. You want it to activate in the hallway before it gets to the room, right? Don't want it near a shower or a bathroom. Don't want it near the kitchen, right? Because I burn a lot of stuff. I'll activate it, and plus you take a shower a lot. That steam will activate it. So we'll talk about locations as well. Then you got this is photoelectric. Now, ionization detector. Ionization detector is referred to as the invisible products of combustion detector. During a fire, molecules ionize, which separate or change atoms by the loss of gain of electrons as they undergo combustion. The detector has a sensing chamber that samples the air in the room and has a small amount of radioactive material. Know this, americium. The radioactive material is americium. Know that. When the eliminated products of combustion enter the chamber, they sense the electrons freed by radioactive ionization. This current ceases and then activates the alarm. I try and dumb it down through the book to make it easier to understand. But you got to know that radioactive material, americium. The flame detector. It's another type of detector. It's another type of automatic alarm initiating device. It's also known as a light detector. They detect light and ultraviolet wave spectrums and detect light and infrared wave spectrum. Basically, you're detecting flame and heat, okay, as opposed to smoke. These are for the fastest detectors to respond to a fire. They are easily tripped by welding and sunlight. They are best used to monitor large office areas. So when you talk about fastest detector, responding to a fire, not to smoke, but to a fire. So that's what we need for a flame detector, okay? So again, I'm going to show a picture right now of smoke detectors, and some of the students did a pretty good job of this. Here's a picture of your photoelectric versus your ionization, okay? Here's your photoelectric right here. Notice how the smoke enters that thing. There's that beam of light we talk about. As the smoke enters it, that beam of light is broken, okay? And that beam of light refracts right here. Once that beam of light is broken, then that will activate the alarm. Then you talk about your ionization, and again, much more detailed, much more things. You have a radioactive material, americium, all these different particles, and these particles activate when there's through the smoke through americium, and they'll activate because of the mix of the smoke and that ionization, that americium product. Pardon me. Where do you put your smoke detectors? Where do you want them? Well, here's a great recommended locations, right? Where do you want them? Well, do we want them in the hallway or the bedroom? Do we want them bedroom, the hallway? I prefer the bedroom. Where do most people sleep, by the way? In the upstairs, right? In the sleeping areas. We want them in the hallway first, okay? Not in the bedrooms. You can put them in the bedrooms, but first in the hallways. We want them in the stairwells if we can, okay? Do we want them near the kitchen? Do we want them near the kitchen? No, because you burn stuff a lot, right? No. Do you want it in the living room? Well, that's okay. But I want it near the stairwells or the hallways, so that it be alerted first, not inside the bedroom. And then do you want it in the basement? Maybe you don't want it in the basement, okay? Be careful of that as well. So the idea is you want one per floor, 1, 2, 3. So if you have a 3-story house, you want to get 3, okay? One in the basement, one in maybe the hallway or the stairwell, and one in the hallway near the 2 bedrooms, okay? So that's your locations. And then do you want one in the garage? Preferably in the basement as opposed to the garage, okay? And there's different types of detectors, of course. Here's what they call the fire gas detector, okay? Here's your fire gas detector, and these are detectors they talk about heat, okay? Very good for the heat, all right? Works real good. But now what they're using, again, as a fire gas detector, is the not just fire gas detectors, but your carbon monoxide types of detectors. Now, these are the ones I had to replace in my house, and I'm probably doing right now because it's 2020. That being said, they're like those carbon monoxide. I'm not a big fan of carbon monoxide detectors, and they're a mixture, a combination, as they say, is a combination of carbon monoxide and smoke, okay? Carbon monoxide basically senses the air at all times, okay? And so what I'll do is that carbon monoxide detector, if it finds that it doesn't really apply here in California because it doesn't get that cold or hot up here, so we leave a lot of windows and doors open, right? Okay, so a lot of air is flowing in the building, right? But when you're talking about back east during the wintertime or in the Midwest or it's cold, or Tahoe, for that matter, Lake Tahoe, is if you don't have enough air going through, that means that product of air, the CO, that means the drop of percentage of air in the air, that means it's going to activate, because we want 21% oxygen, right? If it drops down a certain level, maybe less than 20%, I think, of oxygen, it's going to activate, because maybe you closed off the window, sealed off the room, and you may have been cooking or something like that. Or in this case, my wife, when she's doing her nails, she uses that stuff to take the nails off, okay? Get rid of it and such. Forgot the product, can't think of my name. Next thing you know was in 5 or 10 minutes, my CO detector activated, because she's breathing in all that bad stuff, not ethanol. It's that stuff to get rid of it. I can't think of it right now. It'll come to me later. But in any case, the air dropped, and that it's constantly sensing the product of air in that CO detector. It'll activate because it's too high. They give a warning alarm, bleep, 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 and then it'll go off because it'll get everybody out. So that's mean is if there's smoke, or in this case, some type of product that's not good, okay? They're extremely sensitive, okay? Like I said, I don't really like them here. We're here in the Bay Area, or moderate temperatures. But when they talk about back east, or it's colder, absolutely, because most times they seal off everything, the doors and the windows. So you need that good temperature rise and stuff like that. Or pardon me, you want to know what's going on in the air inside the house. Okay, whatever is fire gas detector. These are detect the levels of CO2 and CO, carbon dioxide, and carbon monoxide in the atmosphere, which are very high during fire combustion processes. They're fast, but not as fast as a smoke detector. The fire gas detector is fast for fire, but it's not as smoke for the smoke as it is. So you want that smoke detector. Then you have your combination detector. I just kind of touched on it. There are various combinations of devices: heat and smoke detectors, smoke and fire gas detectors, or in this case, carbon monoxide and heat detectors. Those are combinations. Gases released by fire. Know this. Gases released by fire. This means the product of combustion. When there's a fire, what type of products come out of a fire? H2O, water. Carbon dioxide, carbon monoxide, okay? Hydrogen chloride, hydrogen cyanide, hydrogen fluoride, and hydrogen sulfide. All bad stuff. And that CO, that's the worst stuff. Silent killers we talked about earlier. Inspection and testing of fire detection and signaling systems. These must be tested when installed on a continuous basis. The installation afterwards is called an inspection test. Kind of touched on it when I was doing a prevention. When you first do a test for a building, where the first test you do is the inspection test, that first test. And if it passes, then the building's okay to open. So that's the inspection test. Know that as well. Fire department's very representatives must be involved in testing. We're going to use NFPA 72 as that guide. Heat detectors can be tested with hair dryers, heat lamps, or special equipment. Smoke, flame, fire gas detectors can be aerosol sprays or smoke generating devices. I'd like a little aerosol can where I'd spray in the detector when I'm going to do a test. I'd spray like this stuff near a detector. It activates it because it's going to spray it. It's supposed to activate in 5 to 10 seconds. If it does, activates, then it's going to pass its test. If it doesn't, I mean, something's going on, right? All equipment should be cleaned by vacuum cleaners, not by wiping dust or dirt with a cloth. Know this. Instead of when you get a detector, you don't want to wipe it with a cloth. You want to take a vacuum and suck all that bad stuff out, okay? What happens in false alarms is when you go to alarm system, like smoke detectors is you're going to go to people who work on their houses. So the contractors that are doing sanding, okay, on the drywall, okay, drywall back here, drywall behind me, they're sanding it to make nice and smooth. Well, that's a real fine dust, okay? That fine dust and particles fly in the air, and it's sucked into the actual detector and blocks that path, or mix into the americium ionization or ionization or photoelectric. In any case, it activates it, okay? And all of a sudden you're like, hey, and we pull up, and all of a sudden these painters or these drywallers looking at us like, hey, we weren't doing anything. What's going on? Because that dust is so particles is going to activate that alarm. So instead of wiping off the stuff, you want to take a vacuum and suck all that bad stuff out of there, out of that little chamber, okay? Remember that as well. Every month there should be a visual inspection of the entire system with yearly testing. Every year you got to test it, okay? And I think that's it. I'm going to show some pictures. Here's a picture of a smoke detector. You already see the smoke detector. This is canisters. Here's the control unit on the panel. There's that control, the main panel. okay? All these different systems, the main brain, okay? All these things coming into the main brain. This is what they call that where the wires touch. These mentioned earlier about the wires, they melt. They're going to melt, and when they melt, these things are going to touch off and will activate the alarm. There's that bimetallic detector where they're like in a bowstring kind of a thing, and they're displaced right here, but the heat will activate and then create this thing to touch off because the heat will rise, and those will touch and they'll activate the alarm. That's that bimetallic detector. What else I got here for you? There's a different type of alarm bells. Okay. All right. Different types of coding, alarms, different codes for alarms for different buildings I talked about. Definitely at schools. Here's what they call a central station. The alarm sounds here, okay? Alarm sounds like one of the buildings. It's going to activate because it's a complex system, not a simple one. It's going to go to the central station, and then it's go to central station, then activate, and then go to the fire alarm. Oh, wait a minute, there's a better example here. Here's the alarms go to the central station, and then go to dispatch center, and then dispatch center will notify the fire, and the fire will respond, okay? That's that central station. And what else? I got a good one here somewhere. Bear with me here. Oh, here's your fire alarm box. Old school. This has like a glass. They used to break the glass with a little hammer. A little hammer used to hang right here, and you break the glass. And you see the little toggle switch in the glass? That's what you manual pull down. The toggle switch you pull down. Okay. What else? Oh, okay. Here's the, I mentioned at the, we're going to look at an annunciator panel. These are usually in the foyer, the downstairs. And there'll be all these different lights. They'll say first floor, south, second floor, third floor, whatever. And they'll have different type of alarms. Say, oh, okay, this thing's flashing. That means a manual pull alarm on the second floor. Then we'll go up to the second floor to see what's going on. Okay? You have an annunciator panel as you walk into the building. Here's your manual pull alarm. I'm sure you've seen these. Red and white lettering. Your manual pull alarms right here. Okay, there's key, whatever. But you pull this down, or in this case, you pull that down, grab your fingers and pull that down manually. And behind it is just like a little toggle switch right here. You're going to pull that toggle switch down. And they'll activate, that will manually activate the alarm. Okay? And I think that's it. Yep, that's about it. All right, well, my work is done. It's been a pleasure. Okay, teaching you. Hopefully you learned something. I hope that you're using a PowerPoint as well, and like I said, use as a supplement. I'm going to be using some other videos I'll be downloading online as to not only Canvas but in your emails, so it gives you some more information. Any questions, you know how to contact me. Pleasure teaching you. Knock it out for the final, and good luck to you. Be well. It's John P. Keller signing off from Los Monos College and for Fire 103, Fire Protection Systems and Equipment. Be well.